In 2015, AWS released the AWS Well-Architected Framework. They wanted to make sure that your applications are well architected. After working with thousands of customers, the AWS solutions architects have identified a set of core strategies and best practices for architecting systems in the cloud and have codified them in the Well-Architected Framework. Originally, the Well-Architected Framework was based around 4 pillars: security, reliability, performance efficiency, and cost optimization. Each pillar, the guide puts forth a series of design principles and then defines the pillar in detail. Additionally, it outlines a set of best practices for the pillar and profiles a set of questions that will help you to understand where you are with respect to best practices. The questions themselves are open-ended. For example, there is no simple answer to a question, how does your system withstand component failures? Or, how are you planning for recovery? Creating a software system is a lot like constructing a building. If the foundation is not solid, structural problems can undermine the integrity and function of the building. When building technological solutions on AWS, if you neglect the 6 pillars of operational excellency, security, reliability, performance efficiency, cost optimization, and the newly released sustainability, it can become challenging to build a system that delivers on your expectations and requirements. Incorporating these pillars into your architecture helps produce stable and efficient systems. This allows you to focus on the other aspects of design, such as functional requirements. The AWS Well-Architected Framework helps cloud architects build the most secure, high-performing, resilient, and efficient infrastructure possible for their applications. The framework provides a consistent approach for customers and AWS partners like nOps to evaluate architectures and provide guidance to implement designs that scale with your application's needs over time. Let's quickly talk about the 6 pillars. The first one, operational excellence. The operational excellence pillar includes the ability to support development and run workloads efficiently, gain insight into their operation, and continuously improve supporting processes and procedures to deliver business value. Some of the best practices for operational excellence are operation teams need to understand their business and the customer's needs so that they can support business outcomes. Ops creates and uses procedures to respond to operational events and validates their effectiveness to support businesses' needs. Ops also collects metrics that are used to measure the achievement of desired business outcomes. The next pillar, security. The security pillar includes the ability to protect data, systems, and assets to take advantage of the cloud technologies to improve your security. Some of the best practices: before you architect any workload, you need to put in place practices that influence security. You'll want to control who can do what. In addition, you'll want to be able to identify security instances, protect your systems and services, and maintain the confidential and integrity of data through the data protection. The next pillar, reliability. The reliability pillar encompasses the ability of a workload to perform its intended function correctly and consistently when it's expected to. This includes the ability to operate and test the workloads through total lifecycle. Best practices include, before building any systems, foundational requirements that influence reliability should be in place. For example, you must have sufficient network bandwidth to your data center. These requirements are sometimes neglected because they're beyond a single project scope. With AWS and nOps, however, most of the foundational requirements are already incorporated and can be assessed and addressed when needed. The cloud is designed to be nearly limitless, so it's the responsibility of AWS and nOps to satisfy the requirements for sufficient networking compute capacity, leaving you free of change resource sizes and allocations on demand. When nOps full visibility into it, you can visualize the requirements that are needed. The next pillar, performance efficiency. The performance efficiency pillar includes the ability to use computing resources efficiently to meet system requirements and to maintain the efficiency as demand changes and technologies evolve. Some of the best practices: take a data-driven approach to building a high-performance architecture. Gather the data on all aspects of architecture from a high-level design to the selection and configuration of resource types. Reviewing your choices on a regular basis ensures you're taking advantage of the continually evolving AWS cloud. But this also comes into the form of right sizing, which includes the performance efficiency, which leads us to our next pillar of cost optimization. The cost optimization pillar includes the ability to run systems to deliver business value at the lowest price point. Some of the best practices are, as with the other pillars, there are trade-offs to consider. For example, do you want to optimize for speed to market or for cost? In some cases, it's best to optimize for speed. Go on the market quickly, shipping new features or simply meeting a deadline, rather than investing in upfront cost optimization. The last pillar, which was just released within the last 6 months, was the sustainability pillar. The discipline of sustainability addresses the long-term environmental, economic, and social impact of your business activities. Some of those best practices are choosing the right AWS region where you will implement workloads based on your business requirements and sustainability goals. Your behavior patterns can help you identify improvements to meet sustainability goals. For example, scale infrastructure down when not needed. Position resources to limit the network requirement for users to consume and remove unused assets. The definition of a workload. A workload is a collection of resources and code that delivers business value, such as a customer-facing application or back-end process. A workload might consist of a substance of resources in a single AWS account, or can be a collection of multiple resources spanning multiple AWS accounts. A small business might only have a few workloads, while a large enterprise might have thousands of workloads. Within the AWS console and the Well-Architected Framework tool, you can specify a workload, indicate its properties, account information, architectural design, industry type, and tags when creating it. Additionally, you can create a workload off a specific lens. Traditionally, performing an AWS Well-Architected Framework review on a workload takes about 8 hours through the questions and answers. Now remember, there's no right or wrong answers, but it's more of an informative in getting the right people in the right room at the right time in order to answer these questions honestly about their workload. Now, 8 hours per workload seems like a lot of time, in which it is to evaluate each aspect of a workload. Within the nOps console, you can easily create new workloads that help you identify security issues, cost issues, reliability, operational performance, and the new sustainability pillar. This allows you to evaluate a workload or multiple workloads for compliancy utilizing HIPAA, maybe it's production, CIS, or SOC 2. For complete visibility within your workload summary with total resources including all the regions, nOps allows you to identify those workloads outlined by the AWS Well-Architected best practices. When viewing the workload assessment within the nOps console underneath the Compliancy tab, you can easily see and identify additional lens types for visibility within a wafer, serverless, SOC 2, CIS, and HIPAA. Now, looking at the assessment itself, it quickly evaluates your environment for the workload specifically. Now, to indicate what this time is, a traditional workload assessment or well-architected review takes about 8 hours, but completing it with 40% automatically utilizing nOps, it helps you dive deep into the well-architected review process and ask specific questions around the workload. Now, these are easily achieved not only within the nOps console, but also doing additional rules and processes in place. The AWS Well-Architected Framework is a living, breathing document. They're continuously added and updated, and you can add your own question types to evaluate a workload within your AWS account. Now, the AWS framework does not only apply to workloads that are in AWS, but can apply in a subset of benefits and factors for workloads running on your remote environment. Looking at the nOps console, it's nice to see and easily identify unanswered questions, medium, high, none, or applicable risk assessment to the workload that's been automatically done and scanned for you. This continuous scan and evaluation allows you to create what are called milestones to an AWS Well-Architected Framework for continuous improvement and should be done and evaluated almost every 6 months. Let's review the AWS Well-Architected Framework security pillar within the AWS console. Taking a look at the first question, or the ability of the tool, you can select a number of things like the question doesn't apply for this specific workload. You can also mark that the AWS best practices do not apply to this workload specifically for each of the questions. And then you have a section where you can add notes. These notes are completely optional. Over on the right-hand side, you have helpful resources to help you answer these specific questions. Taking this a step further within the nOps console for the security pillar and this same and specific question, it's nice to note that this takes it just a little bit further and really outlines some of the business cases or use cases on how you can advance the question or add more to it. You can create things like attach resources, workloads, create a Jira ticket to do it, attach a discovery, and even further. This is done automatically for a number of the questions, taking the AWS Well-Architected Framework a step further so that you can highly evaluate your AWS workloads. Now let's move on to cost control. Recently, with how the market is lately, cost resources are a highly important topic. Within the nOps console, cost control is one of the first things that you could look at or visually see. Easily identify your spending summary day over day, month over month between your resources and various public clouds. You can easily identify not only the cloud accounts, but the regions in which you're spending the most cost for those resources, including what cloud services that you're highly using and are costing the most money, not only month over month, but day over day, and the changes that apply to them. In the next session, I'll be actually talking about change management. Now, within the cloud cost resource section, you can look at the resources that are spending the most within your entire public cloud accounts, or you can filter them off onto other and specific AWS or Azure accounts. What about non-resources? Well, some of those things that have been identified from AWS that are non-resources, an example of CloudTrail is one of them, AWS Config, and GuardDuty. These are managed services provided by AWS. It's nice to see the visibility within them and the total cost associated to them because that's not something that's highly available and visible to everyone else. Another thing you can look at is the usage types. What type of services is your account using for AWS resources? What I like about the nOps console is that it actually easily identifies not only your NAT gateways, your data transfer costs, some other usage and resources that are being consumed that are not easily visible when you look in the AWS console or account, but show up within the nOps console where some and potentially high costs could be associated to and potentially cost savings. The next thing I like to look at is the operations. And this is not some of the operational costs, but the cost that's associated with your account. From creating actual resources within AWS, those operations do cost money. From domain to creating GP3 instances. Those are just to name a few that are easily identified within the console for recognition of some commands or resources that you're utilizing in order to create them. One of the last sections I wanted to talk about or show is the actual tagging structure. Now, we do have a section for untagged or a tag explorer that shows all the resources that are potentially untagged and associated with somebody else or a product or production owner. These tag resources will help you easily identify what resources are created, not only using infrastructure as code, but the resources that might be created through other automation tasks like CloudFormation, Terraform, maybe easily provision one. Now you can associate them with some chargeback, showback. The last thing I'd like to talk about is change management. Change management is crucial. A lot of companies are using ITSM tools, an example like ServiceNow, Jira, where you can track changes that are happening within your environment to understand where some of the cost is being associated with. This change might be going up or down, right sizing, deleting, removing resources, but you'd like to easily identify what's happening in an environment. You can do a cost change management or nOps rules change management. Within the nOps rules change management, we can see details associated with that change that's happening in near real time. The next thing I'd like to talk about is our GraphQL IDE interface. Precise data when you need it. Within the GraphQL IDE interface, you can go into the Explorer and look for your favorite query automatically available to you. You can even filter the results. But what about saved queries? No problem. If you look at the saved queries, we have a number of them already available specifically to an account. You can easily click on them, run them, to find out the information that is needed exactly when you need it. How do you get to the GraphQL IDE interface? Within the nOps console, press Command-K, type IDE, and select GraphQL. Now, how does this translate back to a well-architected review? I'm going back into the nOps console, and I'll look specifically for my workload. And within the workload assessment, under the compliance ops, I can click on one of the pillars, and for one of the questions, click Attach a Query. When I click Attach a Query, it's going to bring up my queries, the private queries that are immediately available to me, meaning that I've already created them, so why not save them? If I click on the query, it'll bring me directly to it, and I can immediately look at the query or edit it. But what about actually running the query directly from the well-architected assessment? When you click the query, you can click on Run. It'll run and provide you the exact data which is in the interface. And I can quickly copy that or look it up or use it for my added benefit. Now I can click on Open it in an editor, and still within this console, it'll bring me back to the GraphQL IDE interface where it's automatically run the query. We can click Save the Query. We can save these either as a private or shared for the organization. On the left-hand side is the Data Explorer, all the data and metadata that's immediately available to you and more. On the right-hand side is the Code Exporter. This Code Exporter allows you to export it into your favorite scripting language, from Python to JavaScript. One of the reasons that we're really talking about security aspects is because the security pillar is one of the top priorities within an AWS Well-Architected Framework review. Within the security dashboard, you can see a number of things that are highly visible to you and your AWS accounts. From following AWS best practices, you'll see a list of maybe IAM users with inline or direct policies. You can override these directly from the console, meaning that they won't pop up for you or indicate that they are a violation. You can see the policies that are attached to the user and how much permissions that they have overall throughout the organization. You'll see compliance, users with IAM permissions, inactive users or accounts that have been detected. These are things that you can see within the AWS console, but when you actually go to visualize them, it sometimes gets tough to manage. Now, you can directly open a Jira ticket to rectify any of the issues. Also, take a look at change management. Possibly something might have changed in the environment. Now, the only way to see this within an AWS console is going through the CloudTrail logs and trying to correlate them with the user or access permissions that have changed. Within the nOps console, we tie that directly to the violations. Other examples of them is you can see violations of users without MFA that tie back to an AWS Well-Architected Framework review on do you have the root or user's MFA enabled. Another key factor for security is unrestricted public access. Now we're talking about maybe possibly EBS snapshots with public access or even EC2 instances with public subnets to open ports. Clicking on the more information or details, you can specifically see any open ports, who they're tied to, and the tags that are associated with it. Now you can override or see the resource details that this is possibly something that you need to keep enabled and no longer will be a violation. Coming back to the AWS Well-Architected Framework assessment, we can look at the security pillar and the questions that are tied directly to it. Within the assessment, we'll see that MFA, is it enabled? How secure are your workloads? How secure is your environment? I want to thank you for this session.